Hi guys, welcome back to the shop. Today the video is actually about boring a TS185 1971 model, but I've got something that I don't normally have and I thought I'd talk about it a little bit. I've got one each of the big three two-strokes from the early 70s, cylinders and pistons. I actually have the Yamaha myself, but I've got a, well, the F7 is mine too, but I've got a TS185 in, so it just happens that I have all three of those. And if you remember in the last boring video I did on the F7, I told you that I didn't have a mandrel in order to hone that. There was just this gap between 2.4 and 2.5 that I didn't have, and I've got that mandrel now, but I'm going to show you that, and I'm going to show you and kind of compare all of those engines, the CT2 Yamaha in this case, the F7 Kawasaki, and the TS185 Suzuki. So let me get you overhead and we'll take a look at these minute. It's, you know, not always do we have something like this where we've got a representation of all three in the shop. So I thought we'd take a look at it. Let's do that. Okay, my bench is kind of full, I apologize. But what we've got set here is, like I said, it's not always that you would have all this stuff in the shop at one time. So I thought it'd be kind of neat to go over it and, you know, just kind of explain the honing situation too. Okay, from left to right, we've got the F7 Kawasaki, the CT1 or CT2 Yamaha, and the TS185. And you can see that there's a big difference in these. These two here, I bore a lot of, and I can use this honing fixture, and this is my favorite. It does the best job, but really they all do a good job. But I can use the double stone, and I can use it with either one of these. And with like the 125s and 100s, I'm using what we call the SL hone, and it's got the bottom, actually this here runs on the cylinder, and it doesn't scratch it or anything. It's made of a soft material. This is aluminum or some variant of it, and the stones are up here, and we constantly go past the stones, and we use a truing fixture, and we use the truing fixture on all of these to keep everything, keep all the stones flat and keep all the stones the same. But these really do a great job. But this is old technology. It's still works great. Most of the cylinders I bore and hone out with these, I keep to a half a thousandths all the way through. And the same with the AN600, this bigger unit. But see, the thing with this covers from 2.5 inches to 6. I believe it's 6. And so I can do a variation of cylinders with this one. Now this is the one I picked up, and it's really a little bit longer than I needed, but it's a 3-stone. I probably could have got by with a 2-stone, but I think this is really going to be a great little tool because you're able to get the whole stroke within the stone area, I think. Only time will tell. We'll be going through this probably next week. Now here are the shoes that I was talking about. These 3 shoes down here replace, you can replace them when they get worn. but these are like brand new. And in this case of the SL, you actually wear the bottom of this here. But like I told you in the other video, you would have to hone hundreds of cylinders to wear those out. That's what they call the non-lifetime, and this is a P28. This is a newer version, and this is what they call a lifetime mandrel, because you can replace the stones, the pieces in here, the ramp and all that, and the shoes. Okay, enough of that. Let's get back to the pistons. As you can see, there's quite a bit of difference, and this is why the F7 Kawasaki, it's so small compared to these. This is a 175, this is a 175, and this one is the 185 Suzuki. And I think during that period you could get a 175 kit for the 185 Suzuki, probably a cylinder and piston, maybe a carburetor. I don't know, I'm not that familiar with it, but I've heard of it, so that you could run in the 175 class. Otherwise, with a 185, you would have to run in the 250 class. Anyhow, you can see that these two pistons are actually pretty close. But this one, compared to the Suzuki, is very small. So let me run through some of the stats here. Just the bare bones here is the Yamaha, the bore is 66, Kawasaki is 61.5, and the Suzuki at 64. And the stroke is 50 on the Yamaha, 58.8 on the Kawasaki, and 57 on the Suzuki. These are all in millimeters. So you can see the Kawasaki is a relatively small bore, but look at the stroke. It's almost as much as the 185 Yamaha, or 185 Suzuki, I'm sorry. But it is the longest stroke of all those and the smaller bore. The Yamaha, the Suzuki, I've had no trouble boring and honing those. And of course I can bore the Kawasaki too, but I needed to get that. It was just in a sweet spot that I didn't have honing capability for. So that's what I had to do. Let's just look at a little bit more of the stats here. The Yamaha, this is it right here. It sported 15.6 horsepower at 7,000 RPM and 11.9 foot-pounds of torque at 5,500 RPM. The Kawasaki, this one actually is the highest horsepower rating of all these, and I'm sure it's because of the rotary valve. 21.5 horsepower at 7,500 RPM. 15.4 foot-pounds of torque at 7,000. And then we get to the Suzuki at 17.5 horsepower at 7,000 and 13.5 foot-pounds at 6,000. So you can see that even though it's a small bore and a long stroke, normally you think of a long stroke being a little bit slower, because they're, it's just normally what they call a square engine, where your bore and stroke is the same. That's, in my time anyway, most people compared that or considered that a pretty much perfect engine, because it had the same size bore and the same size stroke. But, it's not a perfect world. You would expect, in this case, that the Yamaha with the short stroke would be the highest revving engine probably. But that's not so. The 175 Kawasaki actually revs higher, and it's got the most horsepower. So you know, it's just hard to tell. I think that it's all about induction. That's what I think. Now, let's just take a look real quick at the piston weight. That's kind of an interesting thing that we do once in a while. Get this thing fired up. I'm going to go with grams, and this is the TS185, and we're setting at 206 grams. On to the Yamaha, 187 grams. And the F7 Kawasaki, 183 grams. That probably contributes a lot to the high revving capability. They've kept the weight down on that. It's the lowest weight, the highest revving, the most horsepower, the smaller bore, and the longest stroke, and puts out the most foot-pounds of torque. So all things aside, the Kawasaki was really a performer in the 70s, and actually still is. You know, those of us that love the old bikes, I've never messed with that many of them, and I'm kind of sorry about that over the years because, you know, I just didn't have any. And the one thing that I always was a drawback to me was how wide the engine cases were, because the carburetor had to be in there. And I remember going out to the flat track races, and you would see these rotary valve engines, and they had a longer intake on them and a carburetor sticking out there with a big sock air cleaner on it, sticking a foot away from the engine, or it seemed like. And of course you're going left all the time anyway, so it doesn't matter, it's sticking up here in the air on the right. But those things were screamers. They just weren't, I guess, run-of-the-mill or whatever. They just were a little bit weird because of the carburetor where it had to be and the width of the cases. But it just wasn't, it didn't meet the conventional standard that the Suzuki and the Yamaha did with a piston port induction or reed valve induction. But anyhow, hey, I just thought that'd be kind of neat to go over that and just show you. And look at the, you know, I'll try to get these set up where so you can see the size of the piston. I believe I've got them pretty much lined up with the crowns here. And you can see right away that the 185 Suzuki is a lot longer, and the 175 Yamaha is the shortest one of them. Just food for thought, guys. Let's get set up to bore a TS185. Okay, just take a look at it real quick. Got a little scoring. Now, I don't have the piston, the old piston for this. I just got the new one, so I can't really tell you what the clearance was, but it's got quite a bit of scoring in essentially 4 quadrants. Here, 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 and here. So I think it was pretty loose. That's what it sounded like from the gentleman that it belongs to. You know, it's already at 0.5, so we're going to go to we're going to 1, and you know, it'll set there. It goes in barely, but just like any of them, they need fitted first. And that's really our only option at that point, is to go with a new bore when they get worn like that. And let's just take a look here and see what we got. Okay, I got 2.5575 on our new piston, and they want that measured at 23 millimeters from the bottom of the skirt. And that's about what I've got there. I've got it marked with the blue. So that's where I'm measuring at. That's in their maintenance manual. And they're calling for 24 thousandths to 28 thousandths, or 60 to 70 millimeter as your piston cylinder clearance. So we'll be trying to get that as close to 24 as we can, probably closer to 23. That's kind of where I'm looking anyway. And we've got our ring gap. That'll be further on down the road. So right now all we've got to really worry about is where to measure here and what our clearance is going to be. And it does have quite a bit of taper and egg shape to it, so it is definitely in need of a rebore. So let me get you down there and we'll kind of get things set up. I'll take you a little more through the setup this time. Okay, something I haven't done for 2 or 3 bores probably is check my tram. I'm the only one use the machine, and I know whether or not I've moved anything, and it's setting just about where it ought to be. Okay, so I just set it at 0 here on the front, and then we'll move it over to the side, and we're still at 0, and around to the back, and we're at 0, and then over to this side, and we're off about 1/1000. So I'm going to go with it. That's good enough. Okay, we just want to make sure everything's good and clean where we're going to bolt everything down. And I get my 1, 2, 3 blocks. These are my good ones that I know are the same and good and flat and true. And I've got some that I can use in other places that it doesn't matter. And I do use some. So let me get the cylinder over here and we'll get her set up. Okay, these being as true as they can, or they are a true set. And you want to make sure that you don't have any divots or gasket material or anything like that on the bottom, because this is where those are going to rest. I generally like to set this up with the exhaust toward the front so I can get the camera up inside. It's just a better situation. And when we're doing that, we need to make sure our blocks are clear of the sides where the tool bit will come out. So we just need to make sure that's clear and we can start bolting it down. And I've got a couple big blocks here that I normally use and a couple of my kind of trashy 1, 2, 3 blocks. And then we'll stick a piece of aluminum up here so we don't mar up the top of the cylinder there. And then try to get that pretty close to level. I think right there is pretty good. Okay, I've got this extra little shaft setting up here. That's for my coaxial indicator, so that when I get ready to true this in, it'll have a stop for it. And that's what I kind of need to get in now is go ahead and get a collet in here. And our indicator. And then I'll go ahead and tighten the drawbar up on it up here. First I gotta get it in gear. All right. So I'm going to try to get that as close as I can here. And you want to get this up as high as you can. Try to get it out of the wear area. Oh boy, I may have to change. I think I'm going to have to put a longer indicator on it. Okay, got a longer one on here so I can kind of reach out there and get that. Now, this is what I'm talking about a stop. I'm gonna put that on the back side here. I think that's long enough, yep. And then we'll just turn it, and let me get you up front here a little bit more. And you can see here, that's how much we're off. So it's not bad. So I can go ahead and fire up the machine. If you're not off a revolution, you're pretty close. So let me fire up the power unit and we'll get going here. Okay, again, we want to get that as close to the top as we can to keep it out of the wear area. I do like to put just a little bit of oil on there so that I don't wear the tip out on my needle there. And then we can just go ahead and fire the milling machine up, and this will bang up against there. And you can see what we've got. And we just adjust the X and the Y until axis until we get it closer. Okay, that's the X. And we must be off a little on the Y. Maybe a little both of them here. I think that's about as close as we're going to get with this one. So once we get this as close as we can, then we'll drop this out and we'll go ahead and get the test indicator in. Okay, so I've got the test indicator in there and I've got it sitting in the back there. Actually, I need to turn that around probably, but it doesn't matter as long as it can read. I can look at this one up here, this just like I can look at the other way. So it's actually off quite a bit. So the coaxial indicator just really gets you close, and then you need something to be able to get her down to the gnat's butt, and that's going to be this, if we can do it, if we don't have a bad spot in here. So I've got it zeroed out right there on the back side, and I bring it around to the front, and we're about almost 3/1000ths off. So we've got to move that, and then we can, what I should do is zero it out here, and then I can work it from the other end. Let me get you back in the stand. Okay, I re-zeroed it up here so I can look at it and adjust it. And what we've got to do is get it about halfway. So we'll try right about there, and then I'll bring it back around here and re-zero. And then bring it back around to the back, and there we are, right on zero. Kind of surprised myself. Okay, and then we do the same to the other side. Well, it doesn't look too bad. Okay, so I'm around to the left side, and it's just, oh, maybe 1/4 off. And then we bring it around to the other side, and we're about 1/1000ths off on the same side. So let me see if I can do something, but I think that's probably going to be pretty close. Okay, let's look at it there. We'll re-zero. And we're at zero there. Okay, so I'm going to keep working on this and get it right. Okay, so we're at zero there. Come around to the back, and we're just about zero, about 1/4 and we're at zero, and we're at zero. So we're in good shape there. So I'll come up here and go ahead and zero out my DRO, and then I'll go ahead and lock all my axes, and then we'll, if we need to make some adjustments, then we probably will. We'll do that at that time, and then we'll start getting ready for the bore. Okay, so I've got the axes locked. I'm setting on zero there. And I'm zero on the back. Zero on the side. And about 1/4 off on the other side. We're going to go right there. Okay. Well, that's about as centered as we get, I think. So we're going to get started here. Still on the first trip. Hadn't really changed much. Okay, it's the first trip, and most of it came out of the front. There's a pretty good low spot right there, but it's sweeping around both sides, or top and bottom of it, and we're cutting all the way down on this side, but it just started hitting it right up here. So it's just different inductions that cause it to wear differently, I think. So onward and upward, I'm going to dial in another 2. Winter's not wanting to give up its hold here. So it's been kind of raining all morning. Now it's turning to snow. Spring. Dogs woke up. I woke the dogs from their slumber. One barks, the other one barks. But anyhow, we're on our second trip, and it's cutting a little more evenly now. Yeah, winter just, this is just normal here in the spring. You get a little snow one day, the next day it's 60, 70 degrees and rain. And, you know, come August, it just dries up and there's nothing until December again. But not always. Sometimes it surprises us. Okay, third trip through, another 2, and it's cutting all the way around right now, but it's probably, when you get down closer to the ports, there's a few spots looks like already that it's not, but at least we're starting to be consistent all the way around at what, about 6 thousandths. Yeah, there's going to be one little spot left kind of over by that bolt hole on the intake side. You can kind of see it forming there now. So I'll dial in another 2 and let's see what the piston looks like here. Probably not going to go in very far. Yep, just to the rings, or just past the ring lands. We got plenty to go yet. Good 8 thousandths. Dial in 2 more. All right, let's do it again. Let's see where we're at. Looks like it's just about got her cleaned up. Yeah, not much left. Let's see where we're at on our piston. Yeah, a little ways yet to go. Yeah, let me get you off here so I can show you where we're at. Everything but just below, just barely above the intake and down to the bottom. Everything else is good. So let me dial in another 2. That scoring over there was pretty deep. Okay guys, this one didn't turn out the way I was hoping. It's got a little bit of some scoring here that didn't clean up. I'm not sure how good you're going to be able to see this. I'll try to put a still up. It's just below the intake port. Everything above did okay. It's just this little bit from the bottom of the port here to about right here. And the rest of it cleaned up nicely. It just was too much and I called the owner, and he said that it was stuck, the piston was stuck, and that's probably the deal. It just was just a little too much there to clean up. Let me find a better light. Sometimes I wonder if it's a better light. Usually it kind of blinds you. You can just see the scratches there. I think it'll be okay because it's everything is cleaned up above it, and that's where your rings are going to be. I really don't see a problem with that. It might scratch the piston a little bit right there, but not any more than it was. But we got there by the skin of our teeth, and I just I had to shut down the boring because I knew I was getting real close. So I took it over and finished it up on the hone real quick, and I just didn't want to go over. And I went ahead and went to 2.5 thousandths on the and that's what they want you to go to. That's what they actually called for. I like to go a little less than that, but we've got our mark here at 23 millimeter, and we went over this at the beginning. Okay, I got 2.5572. And on the bore, we got 2.5597. Let me grab it again real quick just to make sure. That's what I had got over at the honing machine. Yep. And the same, 2.557, so that's 2.5 thousandths. And I've already plugged that into my dial bore gauge. Two and a half, kind of 2.5 to 2.4 there on that one. Two and a half. So I'm happy with the bore, but I'm just a little disappointed that it didn't clean up all the way. But I think it'll be fine. I just didn't want to go too far. That was my thought when I got to it was pretty far up. I'd got to way above here, and I usually like just to go to the bottom of the pin and I was up to about here, and I go, well, I'm going to shut down this boring thing and take it over and try it on the hone and to finish it up and see how close I can get. And that's what I did. You know, it's disappointing when you can't get there, but I think that'll be okay. Everything's good up in the ring area, so I think this will be a good runner for him. But when they stick like that, some of them are pretty deep, and I could tell before I even started that there was some deep ones there. So it doesn't always work out, but I think in this case it just barely did. Okay guys, there you have it. You know, I don't like it when they don't clean up, but you know, you've got what you've got. You've got a cylinder and you've got an oversized piston, and you got to do what you have to do. I know some people will look at what they're doing when they start and try to freehand it, kind of move it in a thousandths or something like that. You know, I've done that before in the past, and I just don't like doing it. You've got to trust your machine and your measurements. I go ahead, I scan the top of it, I get it the best I can. See, another thing is this one had already been bored once to a ½ millimeter over. So you don't know how true they were when they were boring it. So I just bore it with the best indicator that I can, and it is what it is. This is the first one that hadn't cleaned up in a long time, but it's probably because it was stock and things were just a little deeper than what we thought. But I hate going in there and trying to move things. I know some people do, but I've had a couple instances like that in the past, and it didn't end well. So I trust my equipment, and if it doesn't go like it did with this one, it just is what it is. We can, if we really need to, we can go to a Wiseco and go to 40 over. But I don't see a problem with it. I think this is going to run just fine. It cleaned up above where the rings are, so everything's going to seal. Just don't think there's going to be an issue. But still, I hate it when that happens. Okay, we kind of had the introduction there with the different pistons. I just wanted to cover that because I don't very often have all that kind of stuff in to compare at one time, and I just thought it was interesting that you know, what got me thinking about it was a smaller honing mandrel for the Kawasaki. And when I got to looking at things, I knew that the piston for the F7 was a lot smaller, so I just wanted to compare them to the other two, and there's really no comparison. You know, it's kind of the information that I just looked all this stuff up online, and I just thought it was interesting to see the different bores, the different strokes, the weight of the pistons, and all that stuff. So I hope you enjoyed that, and thanks for going along on the ride. See you next video.